Welcome, dear students. Welcome to the last part, or in other words, the required part of this chapter, chapter number 2. Now, here in this part, we will be knowing basically about the quantum numbers. About the quantum numbers. What are quantum numbers? What are its types and why they are required in knowing the structure of an atom. And as the title of the chapter was Structure of Atom, I'll just like to draw one basic thing for you. First of all, the first thing is atom. Inside the atoms, we have shells. In these shells, we have subshells. We have subcells. Inside these subcells, we have orbits. Orbits or orbitals. Orbits. And in these orbits, we have the electrons. This is the basic shape of an atom, means how they are related. Now, in this video, I'll be telling you about the quantum numbers. What are quantum numbers? So, there are basically 4 types of quantum numbers. We will be looking into them one by one. So, the first one is principal quantum number. The first one is principal quantum number. Now, what is principal quantum number? Why it is required in the course of knowing the structure of an atom? So, this principal quantum number, it is nothing. It is just some positive integers, and these positive integers, they determine the number of shell. It determines the shell. Suppose principal quantum number, it is just a positive integer. It is a positive integer. It is a positive integer, comma, which tells us about the shell. It tells us about the shell of an atom. Means this principal quantum number, this is just a positive integer or a positive number which tells us about the shell of an atom. So positive integers, we know what are the positive integers are shown by the number n. So principal quantum number, the symbol is n. N means n starts from positive integers 1, 2, 3, 4. Then if the value of n is 1, the shell that it will represent, it is, we all know this one. This is K, this is L, this will be M, this is N, and so on. And so on. Means this principal quantum number, it will tell us about the shell of atom. Then as the size of an orbital, it increases with the increasing the principal quantum number. Means if we have this K, L, M, N, here the principal quantum number associated with K is 1. The quantum number associated with L is 2. So the L shell is greater than the K shell. Then the next one in this sequence is azimuthal quantum number. The second one, that is number 2, is the azimuthal quantum number. Azimuthal quantum number, and the letter which represents this one is L. Now, what is azimuthal quantum number? As I have already told you in the above, that an atom consists of shells, then it comes the subshells. Then now here, this azimuthal quantum number will tell us about the subshell, that in this cell, suppose the first shell K, in which subshell is the electron present. Then for an azimuthal quantum number L, the given value is that for a given value of n, for a given value of n, comma, the value of L, the value of L is given by 0 to n minus 1. It means that if n is equal to 1, then the value of L will be 0. If the value of n is equal to 2, then the value of L is given equal to from 0 to n minus 1. Then what is n minus 1? N is our 2. Then 0 to 2 minus 1. That is, here the value of L will be equal to 0, 1. Next, if n is equal to 3, then the value of L will be from 0 to n minus 1. It means this time from 3 minus 1. That will be equal to 0 to 2. That is 0, 1, 2, and so on. And so on. Then these azimuthal quantum number 0, 0, 1, 0, 1, 2 means the value of L. This will give the subshell. Now, what are the representation of these subshells? How they are denoted or how they are designated? What are the denotions for this one? I'll be showing you that one now. If the value of here, if the value of L is 0, it is denoted by S. So if the value of L is 0, denotion, if the value of L is 0, it will be S. If the value is 1, it will be P. If it is 2, it will be D. 3, then F. In this way. Okay? Then now from here, we are moving towards the third quantum number. The third quantum number is the magnetic spin or the spin quantum number, which is given by F. It is spin quantum number or the magnetic orbital quantum number. Also it is written with Mn. First let us see the magnetic orbital quantum number, that is M. The third one is magnetic orbital quantum number. Magnetic orbital quantum number. Magnetic orbital quantum number. Now, what is the shape for this one? Magnetic orbital quantum number. It is designated by M and suffix it is written as I. It gives us the information about the spatial orientation. Means what is the orientation of the orbitals or the subshells, which with respect to their coordinate axis, that we will be knowing when I will be telling you about the shapes of these orbital. For this moment, it's better that the value for any subcell means for any value of L, comma, m is given as twice L plus 1. Means this is the formula for finding m. It's this magnetic quantum number, magnetic orbital quantum number, it is related with L. And this will give us about the orientation. That what is the orientation? And the last one is the electron spin quantum number. The last one is the electron spin quantum number. Number 4 is electron spin quantum number. Electron spin quantum number, it is given as ms. Then for this electron spin quantum number, only two values are possible. That is, one is plus half and the other one is minus half. These two values are fixed for ms. Means either it can be plus half or it can be minus half. So till now, whatever we have learned from there, what we have seen that we have learned till now the principal quantum number, that was n, and the azimuthal quantum number, that is L. Then if the value of n is 1, then this one, the value of L, it can be only 1, that is 0, because it is from 0 to n minus 1. And when the value of L is 0, it is denoted by S. When the value of n is 2, L can have two values, that is one is 0, and when the value of n is 2, it can have another one value, that is 1. So when it is 0, it is shown by S. When it is 1, it is shown by P. And now how to designate that this S is for the first orbital and this S is for the second orbital, or this S is for the first shell and this S is for the second shell. So here the principal quantum number is added in this way, 2S, 2P. Similarly, when it is 3, it can have the values 0. When it is 3, it can have the value 1. And when it is 3, it can also have the value 2. Then, as I have already shown you, when the value is 0, it will be S. When the value is 1, it will be P. When the value is 2, it will be D. Then here, it will be 3, it will be 3, and this will be 3. And so on. In this way, it continues. Now the next is the shape of an orbital. Shapes of orbitals. Shapes of orbitals. Shapes of orbitals. Then what were the orbitals or what were the subshells? Also these subshells, they are known as orbitals. Okay. Subshells are known as orbitals. Then what were the subshells that we have got? The denotation. How they were denoted? They were denoted by S, they were denoted by P, and they were denoted by D. Till now up to D it's okay. Then the shape of S orbital, it is spherical in shape. The shape of S orbital, it is spherical in shape. The shape of P orbital, it is something like that of a dumbbell. It is in the shape of dumbbell. And this D orbital, it is in the shape of a double dumbbell. Something of this type, like a flower, like that of a flower. This is the shape of the D orbital. Now, this P orbital, this again has further 3 suborbitals. Means again this orbital, it has again suborbitals. Then they are designated by px, py and pz orbital. And this d orbital, they have 5. And they have 5 suborbitals. These 5 suborbitals, they are named as dyz. They are named as dyz, dx square minus y square. Then the next one is again dz square. Then dxy and dxz. These are the 5 suborbitals of the d orbital or the d subshells. D orbitals, they are distributed in this shape. Now, what is this px, py and pz? Just a basic thing, you know. This is from the coordinate. This means if this is the y-axis and this is the x-axis in this way, then this px, the px orbital, it is oriented towards the x orbital. Means if this is the x and this is the y orbital, this is x, y dash and this is x dash, then the shape of px, I say that the shape of p orbital is dumbbell shape. And now if it is px, it means that the orientation of this one, it will be in the x orbit, this way. If it is py, it will be in the py. If it is pz, means this third one, the z one. If this is the z orbit, z axis, suppose if this is the z axis, then for pz it will be along the z axis in this way, along this way. This will be the pz orbital. This is the px orbital. And if I am drawing this one in this one in this y-axis, then this will be py. And similarly for this d orbitals, which you can see in your books, in your NCERT textbook, that how the shapes of these d orbitals are drawn. Now next comes the energy of these orbitals, means whose energy will be more and whose energy will be less. Then as I said here that as we are increasing this side, the shape of the shell is increasing. Then also the energy increases as we are moving in this way. So you can see here this one. Here I have written something. So among these two, whose energy will be more? If I am comparing the energy of all these subshells, if I have written here, whatever I have written here, if I am comparing the energies, then the energy of 1s is less than 2s. Again, this is 2 and this is also 2, means the principal quantum number in both the cases, it is same. So these two energies are equal. Twice is equal to twice s. Again, this energy, it is less than that of 3s. Again, all are 3, that is 3p and 3d, they are having equal. Then again, this one will be less than 4s and so on. 4s will be again equal to 4p, then 4d in this way and so on. So it means energy, it is depend on the principal quantum number. Those which are having the principal quantum number the same, they are equal in energy, and those which are means ascending order of these positive integers. So now we are towards the end of this chapter. This is the last topic here, that is electronic configuration. Now you will be thinking that we already know how to write the electronic configuration. So what is new in this case? What is new that we are going to learn here about this electronic configuration? Then here you see now electronic configuration. Now till now you were writing the electronic configuration in terms of shells only. Means if the atomic number, suppose, if the atomic number was 3, then the electronic configuration that you were writing, it was directly 2.1. Means you are directly writing the shells. But from now, you will have to tell about the subshell also, as well as the suborbitals also in some cases, that subshells or suborbitals in which these electrons are residing. Then let's see one by one. So this electronic configuration, it is mainly written on the Aufbau principle. AUFBAU. Aufbau principle. Aufbau principle. Now this principle is nothing new. It just means only that building. Aufbau means building. And if you want to see the table that how this building is built, you have to see your book. But now at present, what I am going to write is that what will be the order of writing this electronic configuration. Then on the basis of Aufbau principle, from now onwards, we will be writing the electronic configuration in this way. First of all, 1s, then 2s, then 2p, 3s, 3p, then 4s, then 3d, then 4p, then 4d, and in this way we will be writing the shape of different electrons from now. Sorry, before our 4p, here it will be 5s. After 4p, it will be 5s. Then after 5s, it will be 4d, and then it will go so on. If you want to know about this, you can check your book. You will be getting the Aufbau principle, that on what basis are the electrons filled in this orbitals. Then now I will tell you how the electrons are filled. First thing is, in every s orbital, will have 2 electrons. Now what I have shown you, the shape of s orbital, it was spherical, but it is not possible for us to always draw this spherical shape. So for our convenience, what we do is, we used to take the shape of all these orbitals in the form of small squares. Then in every one small square, only 2 electrons can go. In every one small square. So in case of S, we will have only 1. In case of P, I have told you that there are 3 P suborbitals further, which are Px, Py, and Pz. Then every P orbital can have 6 electrons. Then this P, it has further 3 suborbitals in this way. Then in one square, 2 electrons can go. Only 2. Means P here 2, 2, 2. In total, it can accommodate 6 electrons. In S, it will have 2 electrons. And in case of D, every D orbital can have 10 electrons. D can have 10 electrons. Why? Because I have already told you that D orbitals are further divided according to their orientation. They are 5. So this will have this 5 squares. 1, 2, 3, 4. Then every square can have 2 electrons. So in this 5 boxes, a total of 10 electrons can go. And now we will be knowing about the different principle that different Hund's rule. Now, what does Hund's rule says, and what is Pauli's exclusion principle? Pauli's exclusion principle is what I have been mentioning, that every box or every orbital, every suborbital, the most perfect term will be that in every suborbital only 2 electrons can be present. Only 2 electrons can be present in one square box. So this type, that is Pauli's exclusion principle. I'll be giving you the notes, you'll be knowing it from there. Next one is the Hund's rule of maximum multiplicity. Now, what does Hund's rule says? We'll be knowing about that. But first of all, let's try to write down the electronic configuration. Let us try to write down the electronic configuration of, let's try to write the electronic configuration of, let's begin with carbon. Electronic configuration of carbon. Then what is the atomic number of carbon? So atomic number, hydrogen, helium, lithium, beryllium, boron, carbon. So the atomic number of carbon is 6. Then now, as per the rule of writing the electronic configuration, if you can move the video above, you can see I have told you that what is the sequence of filling up the orbital. First 1s, then 2s, then 2p. Then now, how many electrons can s orbital have? It can have 2 electrons, maximum 2 electrons. Then this 2 we will have to write in the power. It means that this s is having 2 electrons. Next is 2s. 2s can have again 2 electrons in it. Now 2 plus 2, 4 gun. How many electrons we are left with? 2. Then p can have 2 electrons. So this will be the electronic configuration for carbon. Let's see another. We have written the electronic configuration for carbon. Then let's write down now the electronic configuration for a bigger element. Electronic configuration for, let's write down now for sodium. So electronic configuration for sodium. Then what is the sequence? The sequence is same. It will be same in every case. Then what do we know? First 1s electron. Then sodium, what is the atomic number? Sodium, the atomic number is 11. Now we have to fill this 11 electrons in the orbitals. How? 1s, it can have 2 electrons. Then again 2s, it can have 2 electrons. Then again 2p. Then now 2p can have a maximum of 6 electrons. Then now you count. 6, 7, 8, 9, 10 electrons are gone. And sodium is having how many electrons? 11 electrons. Then in the sequence of this orbital, after 2p, which orbital comes? That is 3s. Now how many electrons we are left with? We are left with only single electron. That is 1. So this will be the electronic configuration for sodium. Means whatever the number of electrons that we are having, we have to fill those electrons in these orbitals according to the order. That s orbital can have a maximum of 2 electrons, p orbitals can have maximum of 6 electrons, and s can have a maximum of 2 electrons, and d can have a maximum of 10 electrons. The sequence being the same in every case throughout the life. Throughout the life I am mentioning, because if you are studying it afterwards also, after your 11th, after your 12th, if you are pursuing something in chemistry, then also the sequence of filling up the electrons will be this one. First 1s, then 2s, then 2p, 3s, 3p, 4s, 3d, 4p, 5s, then 4d. If you want to see the above building principle, you can see your book, NCERT book. Now the final topic here, the final topic is the Hund's rule of maximum multiplicity. Now what is Hund's rule? Hund's rule, H-U-N-D apostrophe S, Hund's rule of maximum multiplicity. Then what does this rule says? Now, Hund's rule of maximum multiplicity says that the pairing of electrons in orbitals belonging to same subshells, that is P, D or F, does not take place until each orbital belonging to that shell has got one electron. That is, it is singly occupied. Means if any atom is there which is having its configuration, means electronic configuration, where the number of electron in the p orbital is 4. Suppose any atom which is having its electronic configuration in which the number of electrons in the p orbital is 4, then what did I say? This p has this 3 subshells. This p has 3, this p orbital is 3 suborbitals. Then here these 4 electrons, first of all will be singly occupied. All of them will be singly occupied. Then the 4th electron will come and it will pair up. Means it won't be like this. This is not the, means it will not be like this, like this one, then this 3, then means here we are giving 2 and then here we are giving 2. Then this won't be followed. This was said by Hund's. Means first of all, if the pairing of electron in the orbital which is belonging to the same subcell, that P, D or F, means only in this case it will happen because S orbital is only having 2 electrons, so S orbital can be paired up. But in case of p orbital further has this suborbitals. Then first of all the orbital will be singly occupied, then only pairing will occur. So this was the last topic of your book, and remaining all the problems that is given at the end of this chapter. What I will say is that this time actually in the wait of this waiting for the new syllabus, I did not manage that one because I thought that it will be removed, but now maximum of them are removed. So whatever I have done till today, you just go up to that, and the assignment which I have given, you go through that and give the coming exam, which will be from Saturday. So with this, I just end this chapter, and if you have any questions on this chapter, you can ask me, you can message me, or you can call me. Thank you.